Geek Wisdom.
Disclaimer: the views and opinions expressed in this article are those of the authors and do not necessarily reflect the opinions of my employer. Examples of ANSYS and code used in this presentation are only examples. They should not be utilized in the real-world projects. They should be considered as based on limited and possibly dated open source information. Assumptions made within this presentation are not reflective of the position of any private or government entity to which the author is presently employed.
Welcome back to our learning presentation on Web Services 201, Part 2, the sequel. Thank you for joining us again today. You recall from our agenda was to talk about what is a web service, some key concepts around web services, and we started getting into how to build a web service in VB.NET, and we called it the old way, the ASMX files. Today we're going to discuss building reservations sort of the new way using the WCF, Windows Communication Foundation. So that's for .NET 4 and above. And if we have some time, we'll talk a little bit about using a Java client to call the WCS web service as an example as well. I also promised to tell you about the secret man behind the curtain, so don't worry, I promise it will come up soon. Now in this example, we're going to expose a web service using the newer technology available in .NET 4 and above called Windows Communication Foundation. And we're going to expose our web service using that instead of the ASMX method, or the older version. So very similar, we're using Visual Studio 2013 Community Edition. And we're going to go create a new project, .NET 4.5. And if we look for service, we'll see it's called a WCF service application. So again, we'll do it in VB. We're going to call it Hotel Reservation WCF, just to keep it separate from our other service. We're going to say OK. Now, very similar to before, we're going to get a stub built for us. One of the things that's going to be interesting is that we actually will see that interface. Before we renamed our file to Hotel Reservation Interface, it actually is using an interface automatically. So what is created for us is a function called getData, and getData using contract. So we're going to get rid of this contract part just for now. We don't really need it. I want you to look at this very similar to the way that you've seen it in the ASMX file. We have a service.vb, and now instead of an ASMX file, it's called an SVC. Now I'm going to go ahead and rename those. And I'm going to call this my hotel reservation interface, just similar to before. And I'm going to rename this to my hotel reservation service. Now, because I renamed them here, similar to before, I'm going to have to call this class the hotel reservation service, and it's implementing the hotel reservation interface. Again, just like before with the ASMX, I have to rename this to hotel reservation service. So it's looking similar to what we've seen before with the ASMX files, except now my class, Hotel Reservation Service, is implementing a hotel reservation interface. My function here is called getData, but we're going to change that. First, we're going to change it in the interface. Public interface hotel reservation interface has an operation contract. So this is similar to how we said web method before, and a function called getData. Again, we're going to get rid of this getData using contract for now. And we're going to call our make reservation. We remember that that takes in a reservation line. Now, in our interface, we don't define any code, so it doesn't have a function end function. This is just our interface into it defining this is what we're exposing. The details are going to be in our hotel reservation SVC file. So this is where you redefine based on that interface. So we have a function here. Again, we have to rename it make reservation. And reservation line. In Visual Basic, you have to say which one you're implementing. So I'm implementing hotel reservation interface dot make reservation. In C#, that's actually not necessary, but so you notice I have this little squiggly here telling me make reservation cannot implement make reservation because there's no matching interface. So the inputs and the outputs of our interface have to be the same as the inputs and outputs of our actual implementation. So here I have reservation line as string. If I go back to the interface, you'll see that I actually forgot to put in the as string, so they don't match in type, so it doesn't see them as the same. Once I make the match in type, the squiggly line goes away. So again, similar to before, we're going to just have this return an empty string for now. I could return something like success or made reservation successfully or something like that. Also, like before, I need to actually implement that code. I'm going to use an existing object that I already have. I'm going to add a reference to that reservation request object. Again, if you're interested in seeing how that object was built, you can check out my video Introduction to Components Architecture 101, where we built that component. And now I'm going to dim reservation request as travel management system hotel reservation request equal to new travel management system hotel reservation request. Oops, that's not right. Dot make reservation line, and then the database. And again, you can see that we actually have a file right now. And it has 1, 2, 3, 4, 5 different entries, Mickey Mouse, Donald Duck, different check-in times, different checkout times, to show what that file looks like. Let's build that. And very similar to before, we need to deploy this. Now we're going to deploy it in this case to Internet Information Server, similar to how we did with the ASMX. One of the advantages over Windows Communication Foundation is that it doesn't have to be deployed in IIS. It could be deployed as a standalone web service. It could be deployed as a Windows web service. But in this case, we're going to host it inside IIS using a very similar method. I'm going to show the files that are in there. And this time what I'm going to copy is the hotel reservation interface SVC file, the bin directory, and the web.config. Very similar to before. Now, there's a little bit of a gotcha. When you do an SVC, you need to define more details about that service within the web.config. Specifically, in the web.config, we're going to need to add some lines that explain how the service works. So what we need to do is put a few special lines in that describe the service in our web.config. And we put that under the service model section. this is basically telling us we have a service called Hotel Reservation Service. So in our service name, our hotel reservation.wcf, that needs to match the name of our project or our namespace. And the second part, hotel reservation service, that needs to match the name of the SVC file, hotel reservation service.svc. Similarly, we create an endpoint and we leave the endpoint address blank so that it will use whatever endpoint it's currently connected to, in this case the local host on IIS. We're going to use the regular HTTP binding, and we're going to use the contract hotel reservation WCF, same as before, but now we're going to refer to the interface, hotel reservation interface. So the same name here goes here, and then we're going to save that. Then we can go to our web service in a web browser. And we're going to refer to hotel reservation service SVC. And similar to before, we'll see that the service is active and it's waiting for us. Few little differences. Before, when we looked at the service in ASMX, we seen the different post messages that would go back and forth. Now we're actually seeing how you would create those clients in code. And there's a test example in C# and a test example in VB being given to us. It's very similar. We access the WSDL by adding that $WSDL to the end to be able to actually use the service. Okay, now similar to before, let's go through an example of we are a company that wants to use this reservation service, and let's build a nice graphical interface for it this time instead of our old green screens from 1986. So let's create a new project. And in this case, let's make it a forms application. In VB, and we'll call it our travel management system. And let's fancy it up a little bit. Let's call this main screen travel management system. Let's build a few labels. Check in date. And let's put a text box. To gather the check-in date. Make sure they come nice together. Let's do a copy of that. Call this one checkout date. Let's make another copy. We'll call this one reservation name. Let's make it a little bigger. Let's give our text boxes useful names that we can use to access them. So we'll get the name property. Call this check-in date. Call this one check-out date. Call this one reservation name. And let's put a little button on there. we'll call our button make reservation. And text for our button. Make reservation. So a little nicer looking than that sort of green screen console-based application. So let's put together our reservation line. Reservation line, similar to before, is going to be equal to our check-in date plus a space, check-out date plus a space, plus our reservation name. No, these should be ampersands. This should be text. Okay, so when we want to actually make a reference to our web service, we're going to go add service reference. Now we will use this address where before we had to go into advanced. This is a .NET 4 SVC file, so we can type the address up there. Just to remind you, this is what the address was. Post that in here. .NET goes out and finds that service. Says yes, we have a hotel reservation service, hotel reservation interface. We'll call this our hotel reservation. We'll say OK. That'll bring in that service. And then again, we access it just as if we were using any other component that we may have brought in. So we're going to dim reservation request as hotel reservation equal to new reservation request. Make reservation, reservation line, and let's tell the user. So request has been submitted to hotel. Build that. Now let's run it. Now we have a nice little graphical box. And let's put in a check-in date, 2018, 06/22, 2018. Now we didn't put any sort of checking around the dates. Obviously we would add that to our interface to make sure that we didn't try to check in after we checked out, stuff like that. Reservation name, this time I will use Freddie Mac. Hit the make reservation button. Should call the service. Come back and tell me reservation request has been successfully submitted to the hotel. And again, now if we look inside our reservations.txt file, you'll see a new one for Freddie Mac on the 22nd to the 23rd. We successfully called that remote service and executed that function. Okay, so just to show everybody the versatility of web services, we're going to do an example of building a web service that was done in .NET, and we're going to call it from a Java application. So we can see here is our ASMX web service that we produced. And we can recall that if I add $WSDL, I will get that web service descriptor language format. Now I'm going to need that as part of importing into a Java client. So I'm going to go to my Linux box. So in our imaginary scenario, we can assume that the hotel reservation service is on a server like the Sheraton Hotels. And now I want to build a client, and I'm stored somewhere else, and I want to be able to make those reservations. So they provided me with their WSDL. They said, here's how our reservation service works. So now I'm responsible for making an actual client that uses that service. So in Java, we use what's called the WS import tool to create the necessary stubs for our Java application. And you pass into it HTTP. Now I happen to know that this system is at 192.168.0.108, and it's called Hotel Reservation Service, ASMX. So the reason I use the 108 here, it's localhost, but these are different servers. So that's its public sort of IP address on my intranet, and then I add the WSDL. Now by itself, that won't work because although it's supposed to be a standard, the .NET version of web services uses a few on-standard settings. So we pass this minus extension, and that tells it to use these special extensions to make sure that everything works okay. Now, the other thing I'm going to pass is what's called minus keep. And as it generates those stubs, it will also leave the Java files that it compiles. So you'll be able to look at those if you want. You don't need to do that. If you don't do that, it'll just compile it and delete the Java when it's done. But with the keep, we'll actually keep those Java files there. So if you want to look at it and see how it put those stubs together. So we're going to run that. It's reading the WSDL. You're getting a warning because it's a non-standard SOAP binding, so that's why I had to use the minus extension, and then it generated a bunch of code. So if I look in that directory now, I'll see that it created a folder called org, and in that folder called org, a folder called travel management system, because that's the namespace that we used when we created a reservation service. So now I'm going to go ahead and I'm going to make a client that calls it. Let's call it Hotel Reservation Client.java. So let's put some code in here. So we're going to import that stub. So that's why we have the import statement, org.travelmanagementsystem.hotelreservationinterface. So we're importing that stub into our system. We have our main class, which has to have the same name as our Java file, Hotel Reservation Java. And we have a main function, similar to what you might see in C#. If you're not familiar with how Java works, you can go look up a Hello World Java tutorial. Just push pause now, and we'll wait a few minutes for you to come back. Okay, so basically, similar to what you've seen in our other application using C# or using VB.NET, we're basically just going to prompt the user for a check-in date, a checkout date, and a reservation name. Then we're going to build that reservation line, which again is just those check-in date with a space and a checkout date and the reservation name. And then the actual code that calls the web service, we're going to instantiate the new object, so a new hotel reservation interface. So this class was created by the WS import command. And then we're going to make that reservation request, and we're going to call its interface called getHotelReservationInterface SOAP. So again, that's just a method of the hotel reservation class that was created by reading the WSDL. And then we're going to assign response to that make reservation. So if you want to compare this to the VB.NET, you'll see it's very similar. It's created this sort of object for us that we can use, that when we call it, we'll remotely call that procedure stored somewhere else on the Sheraton server. and then we send out a message saying we've sent it to the hotel reservation service. Okay, now we can compile that with the JAVAC, the Java compiler. Hotel reservation client. And now we can run it with the Java command, Java hotel reservation client. It'll prompt us for a check-in date, 2019 0101 190201, and we'll put it under the name Mr. Jones. We see reservation sent to hotel server. Now if we were to go look at the database on the server, type reservations.txt, you can see that it added Mr. Jones for those dates. Now let us suppose we want to do the same thing, except for using the ASMX web service, we wanted to use the SVC. So the first thing we need to do is make a little configuration change to our SVC service. If you recall, when we modified the web.config file to make it using WCF, we added this binding, and you can see right here we said WS HTTP binding. So remember that with Windows Communication Foundation, there are multiple different ways to host a web service. We could host it on IIS, but we don't have to. We could also run it as a standalone server, or we could run it as a Windows service. So for this reason, WS HTTP binding allows a lot of different extensions like authentication over the port and different methods of encryption. So the benefit of this is that it's easy to use from within different .NET applications and provides a good layer of security on top that can be used as sort of an extension. The problem is if we want to call it from a Java client, it doesn't work so well because it's a little bit unstandard. So for the improvements in its flexibility, we sort of lack in its ability to have that loose coupling with different applications. But it's easy to solve. All I'm going to do is change from the WS HTTP binding to what's called the basic HTTP binding. And what that means might be basic with a small b. What that means is now it's going to be able to follow the standard conventions and be called by other applications like Java. It also means that it's trusting us to host this on an IIS server so that it can do the main components of IIS, whether it be authentication with IIS or authentication with or security with SSL. It's sort of enforcing that now we're definitely going to put it on an IIS server. It does give us the flexibility that now we'll be able to call it from different clients. So small change there in the configuration to make it work. Okay, so now that we've made that configuration change, we can again run ws import keep extension 192.168.0.108 hotel reservation service, this time .svc, WSDL. Again, WS import reads the WSDL, assuming that we spell HTTP correctly. Now let's create this time a hotel reservation proxy Java file. And this time, instead of prompting the user, we just sort of hard code a string reservation line just to show you how it works. And it's a little bit different, but our object is now called hotel reservation service, which again, we instantiate a new object of that. Our reservation request, we say get basic HTTP binding instead of get binding SOAP. A little bit different, but the same idea. We then call our reservation line, and then we send out our message. So in this case, I expected to set up a new reservation for Mickey Mouse for September 2nd to September 4th. So let's compile that again with Javac. Just to show you our current reservations at our pretend Sheraton hotel. There's our Mr. Jones from before. This time we should set up Mickey Mouse. So we'll Java hotel reservation proxy. We get our message that the reservation's been sent to the server. We look at the server database, and we can see there's our Mickey Mouse, now all set and reserved for his room. Okay, so just to make sure we're all playing along here at home, and to make sure that everybody understands, let's put this all together. Recall that we created a basic web server using sockets in our introduction to components, and we call that listing6.c. And listing6.c has the ability to execute any other program and return its results. We did an example of this with our hello world.html. So this file simply used the XML HTTP request of JavaScript to call something and do a very simple web service. Now I could further extend this to call our make reservation system instead. However, in JavaScript, you can't call servers outside of your local host for security reasons. So what I need to do is I need to make a proxy. So because I built that JavaScript hotel proxy class, and it's now running on this web server, I can call it from localhost of this HTML file. So to do that, I'm going to create an executable script that we'll call make reservation. And it's going to be a bash script. And it is going to go into that training directory, and it's going to execute Java hotel reservation proxy, and it's going to pass whatever command line parameters go to it. Now our hotel reservation proxy instead of the reservation line being hard-coded, and because we know that in the world of the web, under the HTTP protocol, spaces in a URI are %20, so we're going to take those %20s back and change them into spaces. But that gives us that same reservation line, and then the same way we called the service before, and then the message is going to say sent reservation to hotel server. So I'm going to compile that again. So just a reminder, in here we have an executable program, make reservation.sh. Should go to the training hotel proxy. Execute the Java hotel proxy and pass those command line parameters to it. Now to make our hotel HTML file, we're basically going to use the same sort of system that we used before for hello world. So you can see make reservation.html is very similar, only now we're going to take in a reservation name, a check-in date, a check-out date. Our function is called make reservation instead of say hello. But again, it initializes that XML HTTP request object, and it's going to call that script that we created, get make reservation.sh, and it's going to pass in that line. It's probably case sensitive, so let's make sure that we have the same capitals here. Okay, so since a picture is worth 1,000 words, let's show this graphically. So we have a user who's sitting down on his laptop. That's me, and I want to make a hotel reservation at a hotel. But I'm going to contact the travel management system website. Now that could be hosted in Silicon Valley, some system called Expedia or Travelocity. But in our example, it's just a very simple Linux web server that we created, and the address is called 192.168.0.15. So I'm going to go to that server. When I enter my reservation details and hit submit, that server is then going to call that Java proxy client class that we created, which is going to do the actual calling of a web service on a hotel. Let's pretend that it's the Sheraton, and they're running a Windows web service called hotelreservation.svc, and they're running it on 192.168.0.108. So in our example, this is all on the same network, but you could imagine this as being two different machines thousands of miles apart with different systems. The travel management system that calls the Sheraton to set up the hotel reservation. So let's watch and see how that works. First, we're going to start up our server, which remember we run by calling a.out. So now it's waiting for connections. Now I'm the user, so I'm going to go to our web server, which is on port 8888. And it was called what? Hotel make reservation. So we can imagine that this is our fancy web server. Obviously it doesn't look like very fancy, but just pretend. I'm going to put in my check-in details. I'm going to check in on 2019, April 3rd. I want to check out. I'm going to put the reservation under the name David McCarthy. I'm going to hit the Make Reservation button, which should cause the travel management system to update, send a message over to the Sheraton database. You get the message back, sent reservation to hotel server. Now let's pretend we are the hotel server and just take a look at that hotel reservations database. And we can see, look, there's David McCarthy, and he's all registered in our database. So that's basically how web services work. I showed it to you from the point of view of the older style ASMX files. I then showed it from the point of view of the newer WFC, Windows Communication Foundation web services. We then created clients both in .NET using VB in a console app, and we showed it in a Visual Basic Forms app. Then we showed it using a web service on a Linux server, completely different operating system, calling Java and a very simple web server to do the same thing. Now in our last example, we used the term hotel reservation proxy. So what do I mean when I say proxy? So a proxy is something that acts as an intermediary between requests from clients and other servers. So basically it sits in the middle. Information passing from the end user, the client machine, hits the proxy with its request. The proxy system then calls the actual server for the details, gets those details, and sends them back on to the client. In the real world, you can think of this as, if you ever heard of voting by proxy, which is you know who you want to vote for, but say, for example, you can't get to the actual voting location, you can have somebody else cast your vote on your behalf. You're casting your vote by proxy. They're your proxy, and they're acting as your intermediary. So proxies are very useful when we want to do security or balance web load or monitor the user connections. Because we're sitting in the middle, we can log everything that goes back and forth, or even change the information as it goes back and forth to whatever way we please. Now, a web service proxy is what we implemented. So our end user went to the client. The client then, in order to make its call, sent the information to the server, which then sent the information back. There are other kinds of proxies. For example, a SOCKS proxy is a specific protocol that allows us to proxy information over any type of port, not just web services or not just hypertext transfer protocol. And then there's the reverse proxy, which allows us to sort of reverse the process and helps with web balancing, as an example. Okay, as per usual, let's take a few minutes to summarize the details of what we've learned today. Servers expose certain functionality to others in the form of web services. Web services are protocol running on top of the HTTP protocol. The ways of calling web services are REST, Representational State Transfer, and SOAP, the Simple Object Access Protocol. SOAP means we're sending an XML message wrapped in a SOAP envelope, and it's sent over the internet between the client and the server as an XML message. When we do choose to use SOAP, the client program knows how to generate that type of message by reading what's called the WSDL, the Web Service Descriptor Language, and generating the necessary stub classes to make it work. The programmer then uses these stub classes just as if they were attaching any reference, like if it was a dynamic link library, for example. They just see it as a class that they can call as methods. What it actually does is call the method remotely, and that's why it's just a stub class. If we want to call a web service that's hosted outside of our own server, and we want to do it using JavaScript, we need some sort of web service proxy, this sort of man in the middle, to make it work. Now don't mix our next exciting episode, where I'll put this all together and explain the details of how it all works and show you the man behind the curtain.